Let us now formally define Bayes' theorem. Let S be a sample space and E and F are events. Then the probability of F given E would be the probability of F times the probability of E given F all over the probability of F times the probability of E times F, the number on top, plus the probability of F complement times the probability of E times F complement. The probability of F, which is the first event that we know, is known as our prior. This is the knowledge or the probability that we've known before, while the probability of our evidence, that event E, given that our prior is true, is known as the likelihood. And multiplying these probabilities actually give us the probability that our evidence, our prior knowledge, and our new knowledge is true at the same time. Now, as you might have noticed, these are some values that are sometimes not given to us. Now, it will be easy for us to get this because we know F, so it's easy for us to get F complement. What will be a little bit tricky is this one. The probability that our new information is true given that our prior information is not true. Because we want to know, this will give us the total of our, or at least the total probability that our new evidence is true. Now, this new probability that we have solved is what is known as the posterior, or our updated probability, our updated knowledge of our prior, since we already know a new piece of information from the likelihood. One recommended way of thinking about Bayes' theorem is the illustration that we did before. So there you go. I have again another box here for illustration. And since this is our sample space S, we can then illustrate this as a division wherein one part has our prior knowledge or our prior probability, while the other one is not part or the complement of our prior. And since we have a new piece of information here, the probability that our new piece of information is true given that our prior information is true, we then limit it here. So using a different color, we now limit this, the prior information that we know, through here, through the probability that this is true, our new information is true, given our prior information or our prior probability. But since we have a new piece of information, this new piece of information should also have a probability in the other part of our sample space, which is this one here. This is this one, the probability of the complement of our prior, while this one here is the probability. Let's put it up here. I'll just make it a little bit different because they're not always equal here. This is now the probability that our new information is true even though the prior is not true, which is the other part of our sample space. So what we're actually looking for is this area here, or the number, the cardinality of this set, all over this one here, the one encircled in green. So it will be the probability or the number or the cardinality rather of this set all over that set of the one in blue. That is how we compute the probability of our current information given that there's new information given to us. That is Bayes' theorem, named after an English statistician, Thomas Bayes.